Okay, so we're in recursive formulas. So over on the whiteboard, I put the end term stuff because sometimes that helps us write the, well, it doesn't sometimes help us. It helps us write the explicit formula in case we need it. Because I told you yesterday, I'm too lazy to like do recursive formulas past 5. If they want us to find like 9 times, I'm not going to do it. I'm just going to use the explicit formula. So we're going to just jump right into it. So first, I kind of mixed up the problems. I want to see if you can tell the difference between arithmetic and geometry. So let's take a look at the first one. Is the first one arithmetic or geometry? So let's talk one more time. What's the difference between arithmetic and geometric? Arithmetic, like arithmetic, the way you get to the next number is by either adding or subtracting the same amount each time. Geometric means you have to multiply by the same amount each time to get to the next term. So this one is going to be arithmetic because it looks like you're just adding 2. So if we're going to write a recursive rule, the recursive rule, I was hoping you guys would catch on to the pattern by doing the assignment yesterday. But the recursive rule, it's actually not that bad because all you do is start off with this. Every single recursive rule, it has that stuff. It's got a sub n and then a sub n minus 1. The only thing that's that needs to be added to this is the common difference. So the common difference, we said that e equals 2, so we just throw plus 2 at the end. That's the recursive formula. The final part to this is to define where to start. So we say a sub 1 equals 5. It's over there in the list. That's the answer. How about problem 2? Yeah, so it's not arithmetic because to go from 1 to 2, that's plus 1, but then from 2 to 4, that's plus 2. So that's got to be geometric. So if it's geometric, geometric should have the R. What's R in this one? Well, yeah, it's defined as the ratio, but what is it? Like, what's the number? What do you multiply by every single time? Yeah, it's 2. Now, writing a recursive rule for a geometric is almost like this. It's going to start off with a sub n and then a sub n minus 1 on the other side. The only thing that's different is we don't put the r out here at the end because that's where it goes if it's arithmetic. Geometric takes the r and just puts it in the front. So that right there, that's the formula. Now all we have to do is define the first term. So we tell everyone we need to start this pattern from 1. That's it. That's how you write it. Okay? How about the next one? So we're multiplying. Okay, so there's 2 things going on here. So the numbers are getting smaller, right? But it's also changing by a different amount. And there's something that gives away geometric sequences. Sometimes when you have these alternating negatives, you know how I said like positive, negative, that's an indicator that it's probably geometric. So that means you're multiplying by negative. That's why it keeps flipping back and forth. Now the thing is though, it's getting smaller. So we're not actually multiplying by 4. We're dividing by 4. So we don't say r equals 4. If we need to divide, we have to put it as 1/4. Now don't forget, you guys, when you find the common difference, oh yeah, it actually is. It's supposed to be negative. But what I was about to say is when you find the common difference or the common ratio, whichever one it is for whichever sequence it is, it has to be the right one on top of the left one or the right one minus the left one. Because if you do the left on top of the right, this right here is going to tell you that it's 4, but it's not. Because if it was 4, these numbers would get larger. So that's not good. It always has to be the right on top of the left. No matter which pair you use, right on top of left. So now to write the recursive rule for it, we always start off with this, no matter what. And on a geometrics are easy because all you have to do is put the R in front. Oh, it's negative. I forgot it again. And then we define our first term. A sub 1. So we're saying start at 64. There's our answer. So if you haven't caught on to the pattern yet, when it's arithmetic and you have to do a recursive rule, you just put the common difference at the end. If it's add, you put plus. If it's a subtract, you put minus. If it's a geometric, you just put the common ratio in the front and multiply it with the previous term. So I think that's pretty straightforward. Okay. Now when it comes to the formulas that I'm going to give you for I'm going to put up on board. I'm not gonna tell you like the recursive stuff. You have to know it. The only stuff I'm going to give you is the nth term stuff. So this will be up on the board when you guys take the test. Everything else you're going to have to kind of know. So you need to know the difference between nth term, explicit, and recursive. Okay. So there's a couple of word problems here, and I think I was going to skip them, but I think we're going to do them because I looked ahead at the test. There's a word problem, so we're going to have to know how to do it. So it says, during your first week of training for a marathon, you run a total of 10 miles. You increase the distance you run each week by 20%. Then it says, write a recursive formula to model this situation. How many miles do you run during your 5th week of training? Okay. So I was thinking about how I was going to explain this, and we need to be very careful in how we sort of interpret some of this stuff. So first of all, the number one thing we have to figure out is it arithmetic or is it geometric? That's the big one. Because if you can just figure out which one it is, writing the formula is not hard at all. But here's the catch. Does anyone even know what 20% of 10 is? It would be 2. You're absolutely right. So in week 1, you would have run 10 miles, and then in week 2, it would have been 12 miles. But here's where it gets tricky. In week 3, now you're going to do 20% of that. So it's not always 20% of 10, so we can't just add 2 every time. So this one is going to be a geometric one. And I'm going to give you a huge hint. Anytime you deal with percents, that's going to be a geometric one. Now here's the other bad thing though. Check this out. When I write this recursive formula, I need to be very careful how I write my 20%. So you guys told me that 20% of 10 is 2, right? I don't want the answer to be 2 though. I want the answer to be the 10 and the additional 2. So the R on this one is a little bit tricky. Now you need to think of this kind of like exponential growth. Remember in an exponential growth function, the rule for R is if it's higher than 1, then it's growth. And if it's 0 point something, then it's decay. If I wrote this as 0.2 for the R, we're going to have a huge problem because it's going to tell us that we're running less each week. Because 0.2 is a decay function. Bless you. Wow, that's like 7 in a row. Okay, so here's what I'm trying to say. Even though the problem says 20%, we need to include the original amount So instead of writing it as 0.2, because remember, we don't put percents into problems, we change them to the decimal, we have to write it as 1.2. So basically that means 120%. So each week, we're going to include the previous week, which is 100%, and then add 20% more to that. So now, the recursive formula for this is not difficult because it follows the same pattern as the ones we did up above. Anytime you write a recursive formula, you put a sub n, and then you put a sub n minus 1. Because we have established that this is a geometric function, all we have to do is take the r and put it out in front and multiply it by that. And then finally, we have to tell everyone where to start from. So we're going to say a sub 1 is equal to 10. That's our recursive rule. So it says, write the recursive formula to model the situation. How many miles do you run during your 5th week? Okay, well, I already know number 1. So remember I said, if I have to go past 5, I'm going to do the explicit. So this is just 5. So week 1 is 10. Week 2 is 1.2 times basically week 1. So I know that week 1 is 10. So I can just take this off. I don't know why the eraser shrunk. And do it times 10. What's 1.2 times 10? You guys have calculators, right? Okay, so in week 2, we ran 12 miles. Yeah, week 2 we ran 12 miles, which makes sense because we're adding 20%. 20% of 10 was 2. So we add that to the original 10, so now we're at 12. Now we go to A3, so week 3. We're going to do 1.2 multiplied by, well, this is going to say week 2, right, the previous week? And I'm going to go ahead and take that off because I know that week 2 we ran 12 miles. What's 1.2 times 12? Exactly 14? Let's do all the decimals. I don't care. 14 point. Okay. So now for week 4, it's 1.2 times week 3. Week 3 was 14.4. Okay. So now we're at 17.28 miles. And then finally, by the time we reach week 5, it's 1.2 times the previous week. 20.736 miles. So guys, the first time we talked about a recursive formula yesterday, I showed you all this work. But did you see all I started doing was putting the last one in? That's all a recursive formula is. Okay, next question. So I was thinking about this, and I wanted to give you one example of each kind. I'm just going to be straight up with you. This is going to be a geometric one also. But see, here's the thing again. See right here where it says it's going to lose 1/4 of its helium each day? I don't want to calculate how much helium we're losing. I want to calculate how much helium we're going to have left. So if I'm losing 1/4, shouldn't I have 3/4 of it left? So in this question, 1/4 is not helpful to me because that would calculate how much we've lost. I want to know how much we have though. So I have to use the other part of it. I have to use the 3/4 for the R. If you want, you can put it as 0.75 because that's 75% of your total value. So it says, suppose a balloon is filled with 5,000 centimeters cubed of helium. It's going to lose 1/4 of its helium each day. Write the recursive rule for the situation, and then how much helium would be left in the balloon at the start of the 7th day. So, okay, 7th day, I'm not going to go that far. I go up to 5. That's my limit. At 7, I'm going to probably just do the explicit formula, and then I'll plug in whatever I have to plug in. Okay, but first, recursive. A sub n equals a sub n minus 1. And because we know it's geometric because it has an r, we put the 3/4 right here. Now that's the formula part, but then we got to tell everyone where to start from. A sub 1 is 5,000. Now this is the answer for the recursive, and I'm not going to do this 7 different times. I just don't want to. So I would use the explicit formula. Now, reminder, here's how you come up with the explicit formula. You just plug in your values into this geometric formula right here. And then you can plug in 7. So using the explicit formula, we have a sub n, and I'm going to put that right here, explicit. A sub n equals the first term is 5,000, multiplied by the rate. We know the rate is 3/4. And then we always do n minus 1. So if they want the 7th day, we put 7 minus 1 up here, and then that can all be done in the calculator. Why am I using 3/4? Because if I use 1/4, that's telling me how much I lost. I want to know how much is left in the balloon. If I'm losing 1/4, doesn't that mean I still have 3/4 left? That's why I'm using the 3/4. I want to create a formula that's going to show me how much helium is in the balloon. If I use the 1/4, it's going to show me how much helium has left the balloon. Is it a big number? Oh, what is it? Anyone type it in? Okay, I'll just put 8-9 whatever. And this is cubic centimeters. So guys, that's really not a big number because we start off with 5,000. So the balloon shrunk. It's only got 889 left out of the 5,000 after 7 days. Okay. Next part. Write the explicit formula and the recursive rule based on the information given. Guys, I'm only going to do 1 because I don't think we need to do 2. And we probably won't even do the last one because it's the same as the other word problems. So let's just do example 6 and then we'll start practicing in the packet. So we've got to write 2 different formulas. Let's see. We've got to write the explicit formula and we've got to write the recursive rule. So in the explicit formula, all we have to do is plug in the information to the geometric formula for the nth term. So a sub n equals, plug in the a sub 1, so that's 3, times, I'll put in parentheses, the -2, and then n minus 1. That's your explicit formula. So in arithmetic, the explicit formula, you plug in a sub 1 and d. In geometric, you just plug in a sub 1 and r. And that's your explicit formula. Now the recursive formula, the way it's going to look depends on whether it's arithmetic or if it's geometric. Which kind is this one? How can you tell? Yeah, because it has an R in it. So in a geometric, it's going to look like this. And then you just stick the R in front. And then you define where to start from, which they've given us also. There it is. Each one of these will give us the same exact answers. However, the explicit is the shortcut when you have to go further than 5. And that's just my personal rule. That's the rule I use. I can crank out 5 answers real quick, but anything after that, I'm going to go straight to the explicit and jump straight to the answer I need. I think that's where I want to stop, because all this stuff is all the same. So you've got the next 30 minutes, no, 25 minutes to practice this. Oh, and probability is back. So remember I told you there's a review section on every assignment? The back page is all probabilities based off the tables.